Hey, I'm Chris, developer evangelist here at Mapbox. I'm going to show you today how to get started with the Mapbox Snowflake Native App, which will allow you to do geocoding, reverse geocoding, and boundary lookup directly from your Snowflake environment. Let's take a quick look at what we're going to cover. Here's a quick overview of what you can do with the Mapbox Snowflake Native App. First of all, it's powered by the Mapbox Geocoding API, which is a service that we've run for several years, but allows you to do a web request to get a JSON response back. So all we're doing is taking that functionality, moving it right inside your Snowflake app so you can just write SQL to call that API and not have to deal with sending out requests and processing, a batch of results and that sort of thing. So it is a set of user-defined functions. So you use them right into your SQL queries. So wherever you would put a field in your select statement, you can actually just pass in the function and say geocode forward, geocode reverse, and you'll see what that looks like in a moment. There's a full suite of options that you can pass in. So it's not just the address string for forward geocoding or the coordinates for reverse geocoding. You can pass in a bounding box to limit your results to only a certain part of the Earth's surface. You can pass in a proximity point and it'll weight the responses, or it'll prefer responses that are closer to that proximity point, etc. So we'll cover that as well. The full geocoder response is a JSON object, so that'll end up in your result set in SQL, but you can pull out what you need. So there's a little bit of extra SQL syntax to pull out the bits and pieces that you need. Finally, boundaries lookup is also available, but it's a stored procedure, not a user-defined function. So a little bit more prep work is necessary, but you'll see what we can do with there. Boundaries lookup basically means given a point on the Earth's surface, we can tell you using the Mapbox boundaries data set, which political boundaries it falls within. So we can say things like neighborhood, we can say things like state or province, country, zip code, etc. So let's jump in and write some SQL and see if we can get started. All right, so I've got a SQL worksheet over here in my Snowflake UI, and the geocode forward function signature, I pasted in here so we can see what it looks like. This, of course, won't run because it's not valid SQL, but for right now, we can see what the different parameters are that we want to pass into the geocode forward function. And this will do forward geocoding, so we can take a fully formed address in a column. So that would be one string that we would pass in here as the first parameter, which would include the house number, the street name, zip code, etc. So depending on what you pass in, the geocoder will return results with different accuracy or different confidence. But hopefully you've got a well-formed string that you can pass in here. So let's see what it looks like with a hard-coded string for now. So we'll do a select. We'll say mapbox.core.geocode forward. And then we don't have to pass in all the parameters. All the rest are optional besides the first one, but the first one is the one that is most important, which is the actual address string. So if we had a table with address strings in it, we would say the field name, but we're not going to do that now. We're just going to do a hard-coded address. So let's do 1600 Pennsylvania Avenue, Washington, D.C., and I will leave off a zip code because I don't know it off the top of my head, but let's see what this gets us. So we're just going to run this and we'll see what shows up in the results. So here's our query. So we have a mapbox.core.geocode forward. It actually used the entire definition of this column as a field name, so we can make that a little prettier, and by just saying as a geocode response. And let's run that again. We'll get a nicer title for our column. Okay, so inside this field, if we click on it, we can scroll through the full JSON response. So this is the response from the Mapbox Geocoding API. If you've ever worked with it before in a web or mobile application, this is how you can fire off as the user searching and get back a point and then move the map to there. But here we're doing bulk geocoding on data, so we don't need all this data. We could totally save this if we want to, but we probably want to pull this apart and grab stuff from inside it. So if you scroll down here, you'll see there's information about like the neighborhood that this address is in. There's information about the zip code that it's in, 20003. So that answers our question. There's information about the municipality and region, etc. But what you probably want so you can actually make maps or do spatial analysis is the latitude and longitude, which are just top-level keys in this JSON response called latitude and longitude. So the next thing you probably want to be familiar with is how to unpack the JSON or pull out nested values inside the JSON. So the simplest way to do that is with a with clause. And we'll say with, let's call this geocode response as, and then we'll wrap this initial query. So we'll say geocoder response a geocode response as a field inside of a table called geocoder response. So we're just going to call this raw JSON. Now, for example, if we just did select star from geocoder response, we should get exactly the same result. Of course, I need to run it with the with clause selected as well. So let's run that. Okay, so we got the same result, but now the field is called raw JSON. So here's what we can do. Instead of selecting all, we can actually pull apart pieces of this JSON, and we can say raw underscore JSON colon. Let's indent that, make it look a little nicer. And let's pull out the longitude field. So this is saying grab the longitude field from the raw JSON as LNG will be our new field name. Let's do a comma, and let's copy this and swap out longitude for latitude. So latitude as lat, and then let's run that. We'll see what we get. So there's our longitude and latitude. And I think just for sanity's sake, if we were to, if we were doing this on the table, we might want to see the original string as well. So let's just change the select up here to include the original string. So we'll do as original address. So we're going to have that hard-coded value in two places. And let's pull this back. No, that looks fine. Okay, and then in addition to selecting the values from inside the JSON, we can also select original underscore address. And let's see what that gets us. So we should see a nice query with the original address and the latitude and longitude after geocoding. And there we have it. Okay, so that's effectively how to use the forward geocode function. So now that we've done it with a hard-coded value, we can do it with a table. And the Mapbox Snowflake app comes with some sample data. So let me just go grab a quick query that we can run, and it'll kind of do exactly what we just did here, but we can see what the response looks like from a real query. All right, so mapbox.sampledata.sample addresses is what this sample table is called. And just so we can get familiar with it, I'm going to run a select star on this table, and we can see what's inside this table. So we've got an address column. So this is our well-formed or fully formed address strings. So we can see, we have, in some cases, the name of a venue, like the hub Orlando. In some cases, we have a full address with an address with a house number. So these are kind of spread out this will be a good test data set to try out the geocoding API. And that's it. There's only a single column here. So we're going to do exactly the same query we did above, but we're going to copy this raw JSON. Actually, let's copy the whole with statement. Instead of hard coding the value, we're just going to grab it from the table. So let's paste this in, and then we'll add this from clause inside the with. Or instead of hard coding this, we'll just say address, because that's the name of the original address field. So we're going to still name that original address. And then same thing, we'll pass it in here to the geocode forward function. So let's do address. And let's see what we get back now. So I'll do select star from geocoder response. And we should see the original address with the JSON response, because we're not actually unpacking the JSON just yet. So sending it off to the geocoder. And not sure how many rows are in this, so we'll find out in a moment here. Keep in mind, we'll execute all these API calls off to the API every time you do this, so you might want to test it out on a smaller set of data. I should probably have added a limit here. Let's scroll down here and see how many rows we actually have. Yeah, 300. So there's 300 rows in this data set. And you can see we have this raw JSON in the response now. So just like we did in the original example, we're going to parse out parts of this JSON. So actually, I'm going to grab the same SQL query, and this should just work because we have an original address column, and then we're going to pull out latitude and longitude. So let's execute all of this together. And let's see what we get. So currently geocoding 300 rows. It's going to show us the result, and we should see a latitude and longitude. There we go. Okay, so we can scroll through and kind of see what this looks like. And you can see I'm not seeing any nulls just yet. So I think you would see nulls if it wasn't able to find any result for these addresses. So this looks pretty good. So next thing we want to do is preview this data. So what I'm going to show here is actually a technique using SQL to turn this into a GeoJSON feature collection. If you're not familiar with GeoJSON, well, it's a web-friendly way to move spatial data around, but it's interoperable with shapefiles and other formats, other vector formats. But essentially, we can get a string right out of our SQL query that will be a valid GeoJSON feature collection, and that's interoperable with lots of other places where we can preview this data, right? Because there's no built-in way in the Snowflake UI to actually see these points on a map. So for now, the best thing we can do is export it as a compatible data format. You can always download it as a CSV, but then you need something that can parse a CSV and knows exactly which column names to look for. Not a huge amount of work, but downloading in a spatial format will actually be a little nicer. So I'm going to go get some sample code. I'll paste it in here, and then we can talk a little bit about what it's doing. This is sample code that'll make a GeoJSON feature collection. All right, so I have this very complex select statement. You can go copy this from our quick start, but effectively this is going to create a GeoJSON feature collection. If you don't know what that means, sit tight, you'll see in just a moment. But essentially, we're just kind of assembling all of the point geometry in a certain way so that it's compliant with this data standard, and then we'll be able to copy the result out and actually preview it somewhere else. So the only things I need to change here, so we still have this with statement that's geocoding our sample data set of 300 rows, but we need to pull out different rows. So for the geometry, it's not just the latitude and longitude columns. Remember, we have to actually grab we have to say geocode response colon in order to get, raw JSON colon in order to pull out the latitude and longitude. Let's do raw JSON. And then in GeoJSON, every feature has properties. So if you're familiar with spatial data, this would be similar to the attribute table in a shapefile. But here we don't have city name as we did in, the example I copied this from, but we do have the original address. So let's do original address, and we'll just grab original address. Everything else is really just kind of manipulating it and moving it all around so that it fits into the structure. The only actual data we're putting in here is the latitude and longitude to form a point geometry, and the original address, which will be a single property. We could have many properties if we want. So then we have to select the correct table. So we want to select from geocoder response, which is in our with clause. Let's grab that. Whoops, geocoder. And let's run all of this together. See if we get back a feature collection. So again, it's running out to geocode all these rows. But you can see we have a single row and a single column called feature collection. If we click on it, we see this JSON structure in the sidebar here. But what's kind of neat is that there's a copy button here, and you can actually click to copy this. So I'm going to copy it, and then I'm going to go to a website called geojson.io. And geojson.io is a website that Mapbox serves for the very simple purpose of previewing, editing, and working with GeoJSON data. So you can actually create your own data in here as well, but for our purposes, I can actually paste in this feature collection, and it actually added a marker to a map that I can interact with right now and preview my data, right? So a lot of people will do data workflows and then send their results to geojson.io just to preview. And so effectively what we're doing here with this query is replicating that experience, where as long as we can get a valid GeoJSON object out of our SQL query, we can go jump over to geojson.io, quickly paste it in and take a look and sanity check it. So the other cool thing I can do here is, because I added, if you look here in the inspector or in the code block over here, I can see the original address property for each one of these markers, and that'll actually be visible in the pop-up as well. So I can come over here and let's take a look at, whatever this one, these bunch of markers are in Portland. If I click on them, we can see the original address string here is 16 Southwest 3rd Avenue. Let's zoom in a little bit further and see if we can. So here's Southwest 3rd Avenue, and looks like 16 is somewhere around here. But anyway, this will be a good way to sanity check this data set. So I'm not going to do anything with it once it's in here. The other cool thing you can do with this GeoJSON response is copy it, save it to a file with a .geojson extension. Then you could open it in QGIS or ArcMap or anything else that will take a GeoJSON file. So that's a fun exercise in order to visualize this data set quickly, sanity check it, make sure you don't have points over in Europe when they're all supposed to be in the United States, etc. So yeah, give that a try, and hopefully this works out for you. The next thing I want to show is another function called geocode structured, and it's the same thing. It's a forward geocoder, but instead of having all of your data in a single column, you may have it spread out across multiple fields. So if you had somebody filling in, or if you have users filling in a address form, they might put their street address in one field. They might put their zip code and their city in two different fields. They might put their country in another field. If the data lives in your database in different columns, this will be the function you want to use. So before we actually run the geocoding structured function, let's create a temporary table called address data with like 5 values in it. So you can see we have a few addresses here we can put into this table. So I'm going to run this query to create the temporary table. And the last line here, of course, is the select star. So this will show us what's in this new temporary table. So you can see we have an address column, city column, state column, and a zip column. So how do we pass these into the geocode structured function? So first, let me post the function signature. Again, this is not valid SQL, but I'll just paste it here so we can look at it and talk about it. So geocode structured has address line 1 as an option or as a parameter, and also has address number and street. So address line 1 is essentially when you have the address number and the street, all together in one string. So a lot of times that'll be in one place. So there's an option to pass them in as one, or you can pass them in as separately as the second and third parameter. So it looks like in our data set here, we have them as one line. So we're probably going to exclude address number and street and just use address line 1. So for now, actually, I'm also going to just get rid of the rest of these, and we're just going to use address line 1. So, okay, so we should use this function signature while we write the SQL. So let's do select, we'll say mapbox.core.geocode structured. Okay, and then let's do our parameters. So address line 1, first parameter will just be the address column. So second parameter and third parameter are address number and street. So we'll just pass in a null for those because we don't have separate address number and street fields. Block we don't need, so we'll pass in a null for that. Place we don't need. Pass in a null for that. And the next one after place is region. So we're going to use that for our state. So we'll pass in the state field. And then what's after state or region is postcode. So we'll use our zip field. And then after region, we have, or after postcode, we have locality, neighborhood, country. So we'll just do nulls for all 3 of those. So we'll just use basically using the default values or not specifying. And let's add from. Let's make this a little smaller so we can see the whole thing. So we're going to say from, and then what's the name of our temporary table? It is address_data. So let's run this query and we'll do some structured geocoding. All right, so just like we did above, we get this JSON response back. The response looks mostly the same and also has that latitude and longitude in it again. So what we can do, let's do the same thing we did before. So we'll say address as original address. Actually, we might want to concatenate that with the city, state, and zip, but we'll just leave it as the address string for now. And we're going to wrap this all into a with. So we'll say, what did we call it before? We'll say geocoder response. So we'll say with geocoder response as, and then put this entire query into the with. So let's indent that a little bit. With this query, we're going to select, and just like we did before, we want to unpack or pull out values from this JSON. So let's call it, first of all, let's give this as raw JSON. So we're going to say select raw JSON colon longitude as LNG, raw JSON latitude as lat. And let's get that original address. So we'll say original underscore address. And where are we selecting this from? We're selecting it from the with table, which is geocoder response. So this should get us a nice result set where we have original address, latitude and longitude for this structured geocode. Let's see what we get. Oh, didn't like that because I don't have a comma there. Let's try again. Okay, structured geocoding happening behind the scenes. And now we have the original address. So again, we're missing the city, state, and zip, but we do have the original line address if we wanted to sanity check this. And then we have a longitude and latitude for each one of these. So there's our structured geocode. So we can do the same thing, how you want to treat these results. You can write them back into another table. You could use a join ID so that you can have your geocodes in one table and not interfere with your raw data somewhere else. So lots of different ways you can manipulate and store this data once you get it back. You might want to save that full JSON response so you can go back and look into it later, because there's a lot more information that'll just be lost if you only pull out the longitude and latitude. But this will get you started with our forward geocoding, where your address is just in a single string, or our structured geocoding, where you have address parts in multiple columns. All right, so in addition to these two forward geocoding functions, we also have reverse geocoding, which is where you can pass in a latitude and longitude, and you'll get back an address string. So that's helpful for when you have location traces, like from a vehicle, GPS, or something like that, and you want to know which address they were in front of or near at a given point in time. You can do a reverse geocode. And we also have what's called a boundary lookup. So it's kind of a point in polygon intersection. So we have a data set called boundaries data, which we curate and maintain with lots and lots of updates, but basically a very reliable set of administrative boundaries throughout the entire world at various different levels. So in the United States, for example, we have zip codes and states and counties, but in other parts of the world, we'll have provinces and whatever other administrative boundaries there are in different areas. So given a point data set, or basically once you have point data, we can do a boundary lookup and make a new column in your data set and look up each one of those points and say, this point is in Maryland, this point is in New York, this point is in California. So that can be very helpful to enrich your data and help you out for making whatever analysis or visualization you want to make downstream. So I hope this was helpful. Take a look at our quick start. Got lots of code snippets you can copy, and also take a look at the documentation for the Mapbox Geocoding API. And hopefully this will get you started. And thanks for checking out the Mapbox Snowflake mobile app. Take care.